Still on polynomials, in this lesson I want to demonstrate the Pascal triangle, how it can help us to expand the polynomial expressions. Right, we have the first degree, we write 1 and 1, we have two terms and the coefficients. So the Pascal triangle shows us the coefficients on each order. So the second order, which is squared, so this to the power 1 and this to the power 2, and these are the coefficients. The first term we have a coefficient of 1, the second term we have a coefficient of 2, and the last term we have a coefficient of 1. You can see that here 2 is coming from adding these numbers on top. 1 plus 1 is 2. Then on the next order, here it's like we have 0, so 0 plus 1 is 1. 1 plus 2 is 3. 2 plus 1 is 3. Then here we don't have anything, we can just say 1 plus 0 is 1. So this is the order for third order or power of 3. And for this third degree, then fourth degree, we do the same here, we don't have anything, so 0 plus 1 is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And the last one is 1. So the first one and the last one, the coefficient is 1. So the fourth degree, we have 5 terms. Here on the third degree we have 4 terms, on the second we have 3 terms. So these are the coefficients. So I want to prove this. I'll give this example: x plus 1 to the power 1. This remains x plus 1. Then x plus 1 squared. It means x squared plus 2x plus 1. If you expand this, you get this quadratic polynomial: x squared plus 2x plus 1. Here my coefficient is 1, here my coefficient is 2, here my coefficient 1, which is highlighted here, 1, 2, 1. So this will be the coefficient. I want you to note something here, that the order here is x squared. So second degree, the degree of the polynomial here is 2, so x squared. Then x plus 1 cubed, here the degree is cubed, and the degree will reduce as we go to the right. The degree of the first term will reduce as we go to the right. So x cubed plus 3x squared plus 3x plus 1. Here it means with x to the power 0, so it's same as 1. So the powers here, the value of the powers will reduce by 1 on the subsequent terms. So the power 3, let's look at the coefficient. Here you have 1, you have 3, you have 3, you have 1. It also means if we expand this, x plus 1 to the power 4, here x to the power 4 plus, here the coefficient is 4, so 4x to the power 3, here the coefficient is 6, so plus 6x squared. Here the coefficient is 4, so plus 4x and plus 1x. So the powers are reducing in order. So this is what Pascal triangle shows us. But there are other elements that I will discuss in this lesson. I will rewrite my Pascal triangle, and I want to expand this. This is a very important concept which is tested in an exam. So if the first term and the last term inside a bracket. So I want to expand this using the Pascal triangle, and let's note the elements. X squared, x plus y squared here. So the first term here, the order will be high here. The degree here will be x squared. Then it reduces to x. X to the power 0 is not written because it is equals to 1. So x squared plus x. You can see that here our second term, it increases from the left to the right, y to the power 0, y to the power 1, y to the power 2. So it starts from the first term as y to the power 0, then here y to the power 1, y to the power 2. Then the coefficient, we then go to the coefficient. It is degree 2, second degree, so it's 1 to 1. So here 1 to 1. Then on the third degree, x plus y to the power 3, x cubed plus the coefficient here is 3, so 3x squared, and here my y starts, here it was y to the power 0, we don't write it because it's 1, then y to the power 1. So as this reduces, this will start to increase, this second term here, which is y. Then the coefficient here is 3, then x, it is reduced, the power is reduced to 1, x to the power 1, and here the power is increased, y squared. So x cubed plus 3x squared y plus 3xy squared plus, the coefficient is 1, you don't write it because it is 1, then x here would become x to the power 0, which is 1, we don't write it, then here is still increasing, the last term will be y to the power 3, y cubed. It also applies on the 40-degree x to the power 4 plus, here this 4 is coming from my coefficient, 4x cubed y, so y is started here, y to the power 1, plus 6x squared y squared, 6 here, this is the coefficient, then 4 here, 4x y to the power 3, then 1 here, y to the power 4. So this is the concept that the second term, will increase from the left to the right, and the first term here will reduce in the same direction from left to the right. As the first term reduces, the second term power value increases. So you just have to make sure that you use the coefficient on the Pascal triangle to expand. Then we want to see how this is tested using the numbers. X plus 3 to the power 1, this is the first degree, nothing changes. Second degrees, now we want to note this, we are taking this as y, therefore x squared plus 2xy, our y here is 3, we replace our y here with 3 plus y squared, which is 3 squared. So the last term will start to increase in power on the second term. So this is 3, this is 3 squared, then we multiply 3 times 2 is 6, 3 squared is 9. So that's how you expand using the Pascal triangle. Then on the third degree, x cubed plus 3x squared, 3 plus 3x, 3 squared plus 3 cubed. You can see that the power of the second term is increasing. Then we multiply 3 times 3 is 9, 3 squared is 9 times 3 is 27, 3 cubed is 27. So this will be our final polynomial expression. You can also be given negative numbers here. So here the last term is -2, the same applies. This is the third degree, these are the coefficients 1, 3, 3, 1, so 1, 3, 3, 1. The x cubed plus x 3x squared minus 2, this minus 2 power 1 plus 3x minus 2 squared plus minus 2 cubed. Then we simplify, minus 2 times 3 is minus 6, here squared removes a negative, therefore this becomes positive 4, 4 times 3 is 12, here it maintains a negative because the power is odd, it will be minus 8. Therefore you can see here that the sign has been affected by minus 2 here. So this will be our final expression. You can also be given the first term as 2x, and you are required to expand. You can use the Pascal triangle. The degree is 3 here, therefore I will use 1, 3, 3, 1. These will be my coefficients. So you can see here that my coefficient 1, 3, 3, 1. Then I will start with the first term as it reduces from the left to the right, 2x cubed plus 3, which is the coefficient 2x squared, the power is reducing, and the last term is now increasing, minus 3 to the power 1 plus 3, which is this coefficient 2x, the power is reduced by 1. Then the last term here, the power is increasing, minus 3 squared plus minus 3 cubed. Then you simplify, use a calculator, always use a calculator at A level. So this will be the final expression, 8x cubed minus 36 x squared, so 3 times 4 is 12 times minus 3 is minus 36, 3 times 2 times 9 is 54 then minus 27. So this will be the final expression. Few things to do. This marks the end of this lesson. Expand this using the Pascal triangle.